Hello everyone, welcome to ProGyanam. I am Dr. PPZ and this is our series Legends of Science. Here we uncover the incredible tales of the brilliant minds who shaped our world. Today we embark on a journey into the life of Isaac Newton, a legendary mind whose ideas transformed our understanding of the universe. Newton emerged as a towering figure in science during the 17th century. His life was a tale of perseverance, innovation, and intellectual brilliance. Newton's pursuit of knowledge led him to unravel the secrets of mathematics, physics, and astronomy, laying the groundwork for revolutionary discoveries. Join us as we uncover the genius of Isaac Newton, a scientist whose ideas inspire and shape modern science. Isaac Newton was born in a quiet village in England in 1642. He was raised by his grandmother after his father passed away before he was born. As a child, like all other scientists, he was also very curious about the world around him. At school, he was a very quiet and thoughtful student. He spent hours lost in his thoughts and sketching ideas. At the age of 12, he was sent to the King's School in Grantham. There, he discovered his interest in the books about mathematics and science. By his teenage years, Newton was engrossed in studying the works of famous scientists of his time, setting the foundation for his future discoveries. His early years laid the groundwork for a brilliant mind eager to unravel the mysteries of the universe. Isaac Newton's impact on mathematics was profound, particularly his role in the development of calculus. His contributions formed the foundation of modern mathematics, although they were surrounded by controversy. Newton and German mathematician Leibniz independently and almost simultaneously developed calculus in the late 17th century. However, their independent discoveries led to a bitter dispute over who deserved credit for the invention of calculus. The calculus priority dispute sparked a heated debate as both claimed priority, resulting in accusations and controversies that lingered for years. Ultimately, the resolution of the dispute recognized the immense contributions of both Newton and Leibniz. While Newton's work predated that of Leibniz, it was the more accessible notations and methods of Leibniz that gained wider acceptance, becoming the standard in calculus. Both Newton and Leibniz are credited as co-founders of calculus, and their contributions shaped the landscape of modern mathematics. Centuries ago, Aristotle's influential beliefs dominated our understanding of motion. According to Aristotle, objects on Earth had a natural place and exhibited two types of motion, natural and violent. However, this understanding prevailed for ages until a revolutionary shift arrived with the experiments of Galileo Galilei that I have explained in our previous video of the series on Galileo Galilei. Galileo's groundbreaking experiments showed that Aristotle's beliefs did not align with reality. Galileo proved that all objects, regardless of weight, fell at the same rate, a revelation that shook the foundations of Aristotle's theories. Fast forward to the 17th century, where a young Isaac Newton embarked on a journey that would revolutionize the very fabric of physics. Through meticulous experiments and mathematical insights, Newton uncovered the laws of motion. These laws served as the bedrock of classical mechanics and transformed our understanding of the physical world. Let's delve deeper into Newton's laws. Newton's first law changed our understanding of motion. It states that an object remains at rest or in uniform motion unless acted upon by an external force. This concept introduced the idea of inertia, resisting changes in an object's state of motion. Newton's second law mathematically quantified the relationship between force, mass, and acceleration. It states that the force acting on an object is equal to the rate of change of its momentum, and it is in the same direction as the force applied. This law is mathematically expressed as F equal to ma, where F is the force applied, m is the mass of the object, and a is acceleration produced. This law became a cornerstone in understanding how forces influence motion. Newton's third law revealed a fundamental truth about object interactions. It states that for every action, there is an equal and opposite reaction. This law revolutionized our understanding of how forces interact in pairs. Newton's laws of motion transformed the field of physics, merging empirical observations with precise mathematical formulations. These laws stand as pillars of modern physics, forever altering the comprehension of our physical world. In the early 1660s, when a deadly plague closed Cambridge University, a young and curious Isaac Newton spent time alone on his family's farm. Isolated from a formal education, Newton went on a solitary journey of exploration and contemplation. When he was sitting under an apple tree, a famous event occurred. Newton's curious mind was ignited as he saw an apple fall. Watching it drop, Newton wondered why things fell downwards to earth and not in other directions like upwards or sideways. This moment sparked a chain of profound thoughts and experiments that led Newton to a momentous realization. Newton pondered, experimented, and unraveled the secret behind the apple's fall. His brilliant mind connected the dots, revealing the force that pulls objects towards the earth. He realized that the same force governing the apple's fall also governed the motion of celestial bodies, a universal force that bound the cosmos together. Newton's revelations culminated in his groundbreaking law of universal gravitation, a theory that changed the course of scientific history. Isaac Newton's work about motion and gravity were encapsulated within a manuscript titled Mathematical Principles of Natural Philosophy, a comprehensive work unveiling his laws of motion and the theory of gravity. However, Newton hesitated to share his monumental discoveries with the world. For years, this knowledge remained hidden from public. In 1684, Edmund Halley, a fellow scientist and admirer of Newton's work, visited him to ask a question about the orbits of planets. Intrigued by this, Newton realized that he had already solved this problem years earlier, but had not published it. He searched for the papers but could not find the required calculations, so he recalculated the orbits of the planets around the Sun and sent to Halley. Halley, recognizing the significance of Newton's findings, urged him to publish the work. In 1687, after years of meticulous work and Halley's support, Mathematical Principles of Natural Philosophy was published. This great publication transformed scientific thought and laid the foundation for classical mechanics and modern physics. Isaac Newton's interest in light led to pioneering discoveries in optics and color theory, transforming our understanding of the nature of light. Newton's experiments involved passing a beam of sunlight through a glass prism. He observed that the prism reflected light, splitting it into a spectrum of colors, forming a rainbow of vivid hues. His experiments revealed that white light is composed of a spectrum of colors, what we now know as the visible light spectrum. These experiments led to the formulation of his color wheel, a representation of primary colors that when combined produce secondary colors. Newton's theories on the composition of light and the nature of colors laid the basis for modern optics. Newton's seminal work, Optics, published in 1704, documented his experiments and theories on light, colors, and the nature of optics. In optics, Newton introduced his theory of the corpuscular nature of light, proposing that light consists of tiny particles or corpuscles, each associated with a specific color and behavior. His work in optics influenced subsequent generations of scientists and laid the groundwork for the wave-particle duality theory in modern physics. Apart from his scientific work, Isaac Newton devoted much of his time to alchemy, an ancient pursuit aiming to turn ordinary metals into gold and find a potion for eternal life. Newton was captivated by alchemical studies, conducting experiments and transcribing copious notes on alchemical processes. He believed alchemy held secrets not only to material transformations but also to unlocking the mysteries of nature. However, Newton kept his alchemical pursuits private as alchemy was considered controversial and outside the scientific norms of his time. Beyond science and alchemy, Newton was deeply engaged in religious and theological studies, devoting extensive time to the interpretations of religious texts. His religious explorations led him to delve into chronology, attempting to decipher ancient biblical prophecies and historical events. Newton's involvement in alchemy and unconventional religious studies sparked controversies and debate among scholars. Newton's legacy remains a subject of ongoing exploration, inviting speculation and discussion about the interplay between his scientific, alchemical, and religious interests. Isaac Newton's enduring legacy extends far beyond his scientific achievements. His never-ending curiosity, rigorous methodologies, and pioneering spirit continue to inspire generations of scientists, philosophers, and scholars. As we reflect on Newton's remarkable life and contributions, we embrace the notion that curiosity, dedication, and the quest for knowledge can shape the course of human understanding, leaving a permanent mark on the fabric of history. Thank you for watching. Stay tuned to ProGyanam for more captivating stories on the legendary scientists. Keep exploring the fascinating world of the legends of science with us.